let's see if this is a factor of the given expression or function f of x being 6x cubed minus x squared plus 2x plus 1. The factor theorem will concern itself on the remainder. If the remainder of the result when we divide a certain function by a binomial expression is exactly equal to 0, that would mean that the given binomial divisor is a factor of the dividend. Our given function here, let's rewrite it here for a better explanation. You have 6x cubed, you have minus x squared plus 2x, and you have plus 1, while our divisor is given as a binomial expression 3x plus 1. So we are going to use here the remainder theorem because the factor theorem talks about a remainder, and it's the remainder theorem which is easiest step for us to solve just the remainder itself. We should look for a certain c coefficient that can be substituted here, and it should be taken from our divisor following this format, x minus c. Since our original divisor is not with 1 numerical coefficient of x, let's divide both of this by 3. Therefore, our divisor could also be written as x plus 1/3. But since the structure for the remainder theorem should be x minus c, we can further rewrite this as x minus negative 1/3. Of course, by double negative property, it will return to plus. This would mean that the c coefficient we are going to substitute here is negative 1/3. Okay, so we are going to substitute here f, or let's have here f of negative 1/3. The result of this, when we change all values of x, or when we change x into a value of negative 1/3, is actually our remainder. This is according to the remainder theorem. And that remainder will further tell us if this is a factor of the other. So let's continue here. We have 6, then you have negative 1/3, then you take its cube, minus negative 1/3 square, plus 2 times negative 1/3 plus 1. Exponentiation first, you have 6. The cube of a negative number is also a negative. 1 over 27. The cube of 1 is 1. The cube of 3 is 27. Here, do not apply the double negative property because we shall start with exponentiation. The square of negative 1 is positive 1. The square of 3 is 9. Here, you can simply multiply this because it automatically means over 1. Positive 2 times negative 1 is negative 2. 1 times 3 is 3. And then you have here plus 1. We can cancel this because this is 3 times 2 and this is 3 times 9. So you have 2 times negative 1 is negative 2 over 9. You have it here minus 1 over 9 minus 2/3 plus 1. To combine all of them, our LCD is 9. Okay? So 9 divided by 9 is just 1, so this is still negative 2. 9 divided by 9 is also 1, so this is still 1, but minus according to the operation here. 9 divided by 3 is 3. Times 2 will have 6, and the operation is also minus. And here, this automatically means over 1. 9 divided by 1 is 9 times 1, so you have plus 9. Look at our numerator. This will give us a result of negative 2, negative 1, negative 6, that's negative 9. Plus 9 is 0. 0 over 9 is 0 itself. This is the remainder when we are going to divide this f of x by g of x here. And now, connecting to our factor theorem, since our remainder is 0, the divisor of 3x plus 1, this one here, g of x, is a factor of f of x. Because according to the factor theorem, if the remainder is 0, automatically the divisor is a factor of the dividend. That's all for today. You're dismissed. And please Do not forget to subscribe now.